So this exercise related to the projectile motion. In 15th century, an explanation for a projectile motion went as follows. Like in the 15th century, the projectile motion was explained by using this diagram. When you throw an object, you give the force which we call impetus. It moves in a straight line until it uses up the impetus and fall to the ground. The diagram shows a path which is described. Correct the diagram to show the path followed by a projectile according to modern observation. So what is the path followed by a projectile according to modern observation? So means we just have to complete the motion of this projectile, so it will follow this path. Explain why the projectile follows a path you have drawn, and your answer should include a horizontal reference to horizontal velocity. Like why the projectile will follow this path which we have drawn. So what is the reason for that? The explanation, this is a structured answer which you have to learn. First thing, the projectile, whenever a projectile motion, when we explain the projectile motion, we always refer the points. We'll say that this will have two components of the velocity. The projectile is having two components of the velocity, the horizontal and the vertical. So the projectile has two components of velocity. Horizontal component which does not change throughout the motion, so throughout the motion or during the motion, because air resistance is neglected. That is one thing. And the second thing, the vertical component decrease, or when projectile is going up with constant deceleration, and it will increase when the projectile is going down by 9.8 n meter per second square, and the acceleration and the horizontal vertical component does not affect each other. So horizontal and vertical components are independent of each other. Means the horizontal and vertical component does not affect each other. That is one thing. So it's the same idea what I just explained to you, that when we launch a projectile, the projectile will follow this trajectory. That's the path the projectile will follow. So this will have the two components. One is a horizontal component, another one is a vertical component. The horizontal component does not change throughout the motion because we assume there is no air resistance. Vertical component, when it is going up, it will decrease. When it is coming down, it will increase. But when it is going up, it will decrease by 9.8. And when it is coming down, it will increase by 9.8 every second. And the horizontal and vertical components are independent of each other, means the value of a horizontal component does not affect the value of the vertical component. They are independent of each other. So this is always the case whenever we talk about the projectile motion. Is it clear, this one? Any doubt till this point? Okay. So this is the structure answer which you have to learn whenever they ask explain the projectile motion. So first thing, horizontal component does not change, no acceleration because air resistance is neglected and or not affected by gravity as well. The horizontal motion, and the vertical component, it's decelerating when it is going up and accelerating when it is coming down. When a toy balloon is hit up quickly at an angle, like maybe you have experienced this, if you hit the balloon, when you hit the balloon, it will go up and then it will come down like this vertically. So why the balloon, even though we say the projectile motion should be like this, why the balloon follows the path which was explained in the 15th century? So the reason is that because balloon is not the ideal case, it's a practical case. Like practically what will happen in a projectile motion, we assume no air resistance. But here in case of a balloon, what will happen? When we hit the balloon, it will have the horizontal and the vertical component. The vertical components are decreasing because of the gravity. What about the horizontal component? The horizontal component is also decreasing. Why? Because of the air resistance. So eventually it will not have any horizontal and the vertical component. Like vertical component is zero and horizontal component is zero at a certain height. So as a result, the force of the gravity will pull it down. That's why the balloon will move downward. So why the balloon follow the path which was explained in the 15th century? So first thing we'll mention, like it's not an ideal case, it's a practical case. So in case of a balloon, there's a air resistance acting on the balloon. As a result, the horizontal component will decrease. And at the certain position, the horizontal component will be zero because it is decreasing. So eventually it will be zero. So the gravity will pull the balloon downward. So it will move vertically downwards. No, you cannot say about this the effect, because effect of the gravity is more when objects are heavy. So you cannot say balloon is lighter, so gravity is more on balloon. No, you have to use the concept you will mention, because ideal cases the air resistance is neglected, so the horizontal component does not change. But practical cases, air resistance is considerable for this balloon. So as a result, the horizontal component will decrease, and eventually at the certain height, the horizontal component will be zero. So the balloon will fall downward because of the gravitational pull. So the horizontal component decrease because of air resistance at certain heights, and the vertical component is already decreasing because of gravity. So the balloon will reach a certain height with no horizontal and vertical component. So the balloon will move downward because of the gravitational pull. So the balloon only will move downward. So Usually what happens for a projectile, horizontal component does not change. But in case of this, a practical case, horizontal component will change. It decreases, so eventually it will come downward. This is what practically happened. This is the theoretical, the projectile motion. Is it clear, this one? Okay. Next question. This is related to energy. We'll do like, because I have already solved with other student, so I will just solve certain questions. So here, in this question, a student is given the following information for a particular attempt at a goal. Initial velocity of a ball is 4.5. So the ball is launched, like the football is there, 4.5 at an angle of 60. Horizontal distance from a center of a ball to the center of the ring is, and show that the time to travel to the horizontal distance of 1.5 meter is, so like example, student is given the following information and there's a ring here, and this ring is 1.5 meters away. The horizontal distance of the ring to the point, from the point where it is being launched, that is 1.5 meters. In the question, we need the time. So if you need the time, first, whenever the speed is given and the angle is given, we'll work out the horizontal and the vertical component. So 4.5 is the speed, angle is 60. So this will be the horizontal component. Horizontal component of the velocity will be 4.5 cosine 60. And there will be a vertical component that will be 4.5 sine 60. So which component I will use for 1.5 meter distance, horizontal or vertical? Which component is responsible for a distance of 1.5 meter? Horizontal or vertical? Yeah, that's right. Horizontal is responsible. So if horizontal is responsible and in the horizontal there is no acceleration, so we use a formula that speed is distance divided by time, because horizontally there is no acceleration for a projectile, so it's used distance over time. So speed is 4.5 cosine 60. Distance is 1.5 and the time is t. So we just cross multiply, we need t. So t will go there in numerator and 4.5. So this will be t is equals to 1.5 divided by 4.5 cosine 60. What is 4.5 cosine 60? One 1.5 divided by 4.5 cosine 60. What's the answer for this? 1.5 divided by 4.5 cosine 60. That will be 0.66. Okay. 2 by 3 or 0.66 or 0.67. 0.667 seconds. That is the time it will take to reach this. Calculate the vertical displacement of the ball when it travels a horizontal distance of 1.5. Hence, comment whether the goal will be scored. The vertical distance of a ring from a point of release is 0.7 meter. Okay. So, in this case, like there's a ring which is 0.7 meter above the ground and at a distance of 1.5 meter. We hit the ball with a speed of 4.5 meter per second at an angle of 60. This will have the two components, one is a horizontal, one is a vertical. So the question is, calculate the vertical displacement. We want like what will be the height which it will reach. And we know it is taking like 0.667 seconds because that's related to the previous part. So it is taking 0.667 seconds to reach. So we need the vertical height. So how to work out the vertical height? Because in a vertical motion, whenever in a vertical motion, it is decelerating. So we will use the equation of the motion. So what equation of motion? Like we have this height 0.7 meters there, but this is not the height. Maybe the ball might be less than 0.7 meter or more than 0.7 meter. We don't know. So we need this height. So we can use S is equals to ut plus half at square. So S is equals to u. The starting speed is what? So we will 4.5 is there, but we use a vertical component. So vertical component will be 4.5 sine 60. Why we are using the vertical component? Because when we talk about the vertical motion, we always use the vertical component. And we use the equations of the motion as well, because in a vertical plane, it is accelerating or decelerating. So in place of u, the starting speed, we will write 4.5 sine 60. The time is 0.667 plus 1 by 2. Because it's moving against the gravity, so it will be minus 9.8. So we put as negative 9.8. And time is 0.667 square. So when we solve, like this plus minus will be minus. So this will be 4.5 sine 60 times 0.66 minus 1 by 2 into 9.8 into 0.667 square. So when you simplify this, like after solving subtract, so you will get the distance. So means the vertical distance will be 0.41 meter. So means this ball will be only 0.41 meter from the ground. So will it score, like will the ball passes through the ring? Yes or no? The ring is 0.7 meter above the ground and the ball is only 0.4 meter above the ground. So the comment, the ball will not pass through the ring, as the ring is 0.7 meter above the ground. Explain how air resistance would affect the calculation in B1. If there was an air resistance acting, what will happen to this? Even if there was an air resistance acting, so air resistance will affect air resistance will affect the range, because like maybe what we consider the ball is traveling 1.5 meter and at a height of 0.4. But if there was an air resistance acting, it will slow down the motion. So the ball may not cover the same horizontal distance. So the horizontal distance or horizontal component will decrease as well for the ball. Is it clear? How so horizontal component, if it decreases, it will take less time and the height will also decrease. So this was a projectile assignment.